All right, today we're going to pop the hood on artificial intelligence. We're going to see how we can train these incredible models not just harder, but a whole lot smarter. You know, we throw this phrase around all the time, that a model is learning. But have you ever stopped to think about what is really going on under the surface? I mean, how does it actually go from making completely random guesses to getting things right, time after time? Well, at its very core, you can think of it like a hunt. A relentless, single-minded search for the one perfect configuration that gives it the smallest possible error. The answer that's as close to the truth as it can possibly get. So before we get into all the fancy tricks to boost this process, we've got to get the basics down. And that all starts with understanding the fundamental goal, finding minimum loss. So how do we even measure that error? Well, we use something called a loss function. It's basically a scorecard, right? It looks at the model's prediction, compares it to the actual correct answer, and gives it a score. The higher that score, the bigger the error. So our entire mission is to get that score as low as computationally possible. And this is where the whole thing just clicks, visually. Imagine you're standing on this huge rolling landscape. The high peaks, that's where the error is massive. The low valleys, that's where the error is tiny. Our whole job is to find the right settings for our model, we call these weights, that will guide us down, down, down into the absolute lowest point in that loss valley. Okay, so we know our goal. Now, how do we get there efficiently? Well, let's talk about our first major upgrade. Instead of taking this slow, one-step-at-a-time journey, we can make it way more efficient by training in batches. And you can really see the difference here. The old-school, basic way is kind of chaotic. It updates its direction after looking at every single piece of data. The result, this shaky, all-over-the-place zigzag path down the hill. But the fix, mini-batch gradient descent, is so much smarter. We take a small group, a batch, of samples, we average out what they're all telling us, and then we take one solid, confident step. It just makes for a much smoother, way more stable ride down into that valley. Okay, so our path is smoother now. That's a huge win. But what if it's not the fastest path? What if we're taking the scenic route when there's a highway available? Well, that's where our next trick comes in, harnessing the power of momentum. Because here's the new problem we're facing. Even our nice, smooth path can get, well, it can get stuck. Imagine it rolling into a small ditch, what we call a local minimum, and not having enough oomph to get out. Or maybe it's just taking this long, winding, inefficient route. We want to go straight to the bottom, no detours. So the solution here is pretty clever. We give our descent some memory. That's what momentum is all about. It's a technique that looks back at all the steps we've already taken and uses that history to help decide where to go next. It's no longer just about this single step right now. It's about the entire journey we've been on so far. And honestly, the best way to think about this is like a ball rolling downhill. At first, it's slow, but as it keeps going, it picks up speed, right? It builds velocity from its past movements. And that momentum is exactly what helps it power right through those small ditches and bumps. It's not going to get stuck anymore. It's just going to stay on a much more direct path, aiming straight for the bottom. So now we've got speed. We're blasting past obstacles, which is awesome. But sometimes you can have too much of a good thing. All that speed creates a brand new risk. And that leads us to our final and maybe most subtle tactic, the art of slowing down. Think about our ball again. It's now a cannonball, just hurtling down the hill. The danger is that it might be moving so fast that it blows right past the bottom of the valley, our actual target, and starts rolling right up the other side. It completely overshoots the goal. So, how do we stop that from happening? We use something called learning rate decay. It's like gently applying the brakes. When we're way up high on the hill, far from our goal, we take big, giant steps to cover ground quickly. But as we get closer and closer to the bottom, we start to shrink our steps, smaller and smaller, allowing us to make these tiny, precise adjustments as we zero in on that perfect spot. And this chart really just lays it all out. See that? Early on in training, the learning rate, the size of our steps, is high. We're making fast progress. But as we move along, we dial it back. We reduce that rate. We're shifting our strategy from let's explore and find the general area to, okay, now let's fine-tune and nail the exact spot. All right, let's pull back and look at the big picture. We've talked about a few different things, but it's crucial to see that these aren't just a random collection of hacks. This is a toolkit, and a good engineer knows exactly which tool to use and when to perfectly tune the training process. And if you remember one thing today, make it this. Mini batching, that fixes the shaky, zigzag updates. Momentum, that stops us from getting stuck in ditches. And learning rate decay, that keeps us from overshooting the target. Each one is like a different knob on a control panel that we can turn to guide our model on the perfect journey. And this really gets to the heart of the matter. There's a great quote from our source material on this. A true AI engineer's first ritual is understanding backpropagation intimately. And that's so true. Really getting these ideas is what separates someone who just uses the tools from someone who truly understands how to build with them. It's the difference between programming and real engineering. So, that leaves us with a final thought to chew on. We've just walked through this incredible toolkit for steering a model's learning process. We have all these different knobs we can turn, which makes you wonder, right? What other knobs are out there? What other adjustments can we make to turn this journey to the minimum, from something that's just successful into something that's absolutely perfect?